Okay, so this is our last lesson of word problems. These are called mixture problems. And when we are working with mixture problems, I think of like mixing when you bake or mixing concrete or mixing something, but that's not really what it is when we're talking about this kind of math. Basically, what it is that you have two different items and you need to figure out the amount of those items. Or you might need to find out the cost of each of those items. So it's taking two items, two unknowns, and trying to find the value of each of those. So I have here steps to solving mixture problems, and I'm gonna, instead of reading these, I wrote the steps out here. So we're gonna do this first one together. And I need you to really take in the process of what we're doing. Because when it gets to the homework, this is not going to be laid out for you like this, but you can use this as a guide on doing your homework. And on your homework, you will need to create this chart, okay? So let's go ahead and look at this first one. It says a 5-pound bag of almonds and cashews was sold for $12.40 per pound. If the almonds were $10 per pound and the cashews were $14 per pound, how many pounds of each type of nut were purchased? So we're trying to find the number of pounds for both the almonds and the cashews. So we have our two types of objects. Our two types of objects are almonds and cashews. And it's asking the two characteristics of each object. So when we look at the almonds, they tell us the price and they tell us that the units will be pounds. So we have pounds and we have cost. Okay. So we're going to make a table. Okay. And the table will have our two objects and it will have our two characteristics of each of those objects. So on step 4, it says place the types of objects as row headings on the side. So the types of objects would be almonds and cashews. Then it says place the characteristics of each object as the column headings. So we have pounds and we have cost. And then add a bottom to the table for the total of each column. So this is going to be totaled here. So that is how you set up the labels of the table. But now we have to fill in the rest. The rest are going to be expressions representing 1, the pounds of almonds, 2, the cost of almonds. And then we're going to do the pounds of cashews and the cost of cashews. And then we're going to do the totals of pounds and the total of cost. So let's look at this. If based on the description up here, what do we know, if anything, about the pounds of almonds that we have? Do we know anything? Yes. Oh, okay. It says that the total is 5 pounds, right? And so we could put 5 down here for the total number of pounds. Okay. What else do we know about pounds?
$10 per pound. It's almonds for $10 per pound.
Okay, so, and we're talking about cost right there, right? So the almonds here for the cost would be $10 per pound. Do we know how many pounds? No, we don't. So I am going to use the variable A for almonds. We do not know how many pounds of almonds that we have, but we want to know. Now I can't use, I I could use P if I wanted to for pounds, right? But I want to differentiate between the pounds for almonds and the pounds for cashews. And when you get to the bottom, if you just have P, you might forget that P is for almonds, right? So I choose A for almonds. Now, JG pointed out that the cost per pound of almonds would be $10 per pound of almonds. So the cost would be 10A because we do not know how many pounds. Okay, so far, this is what has been given to us. But now we have to look at cashews. We don't know how many pounds of cashews that we have, but we know that there's a total of 5 pounds altogether of almonds and cashews. So what we can do is we could take the 5 pounds, well, let me ask this. Using the same variable A, what expression could we use to say that, to represent cashews? If we know that there's a total of 5, and we know that A represents a certain amount of pounds for the almonds. What if I said, we have 5 pounds of nuts, 3 of those pounds are almonds? What would we do to figure out the number of pounds of cashews? What operation there? I heard, yeah, you would subtract 5 minus 3. Well, here, we don't know what A is. We don't know the number of pounds, but we know that it's going to be 5 minus the number of pounds of almonds. Okay. What is the cost of cashews per pound?
$14.
$14. So we set this up as $14 times 5 minus A, meaning $14 times the amount of cashews, which is 5 pounds minus how many almonds we have. Okay. And then the total cost, how much did we spend altogether? $12.40. Now, when you set up the table and when you set up your equation, do not put dollar signs in there, okay? Do not put units in there, so pounds or ounces or inches or feet or whatever, like that. Just write the numbers out. Okay. So we have fully set up our table. We've labeled it correctly. Now it says to set up an equation. So we know that the total amount of almonds plus the total amount of cashews is going to give us $12.40 that we spent. So we're going to look at this column right here when we do this, okay, when we set up our equation. And I'll write up here that you're going to use this to set up equation, right? All right, so let's set up our equation. We have the amount of all almonds, 10A, plus the amount of cashews, which is 14 times 5 minus A, equals a total cost of $12.40. Now, we just tested and we've been practicing on how to solve equations. So at this point, solving this should be a review, but I'm still going to do it with you because there are still some steps that people are missing on this. We want to do our distributing first, so 14 being distributed to both the 5 and the negative A. So we have 10A plus 5 times 14 is 70 minus 14A equals oh, you know what? We made a mistake. Look, it says $12.40 per pound. What should I have added to the total? Anyone? Yeah, we should have multiplied that by 5. So we're going to multiply this by 5. Okay. So now I am going to do two things. I'm gonna multiply that out, and then I'm gonna combine my like terms over here. Okay? So 10A minus 14A gives me a negative 4A. And then 1240 times 5 gives me, anyone do that on your calculator? Should have gotten 62. All right, now we're going to subtract 70 on both sides. And we get negative 4A equals negative 8. And then we divide by negative 4. And A equals 2. Now remember, if you get to the bottom and you have some negatives when you're dealing with units of measurement or cost, then you know you maybe done something wrong. Is there, I see a couple of wrinkled eyes. Are there any questions about what I did here? Okay. No, okay. I'm glad you said that. No, these are, it's on this, they're both on the same side of the equation. So we combine like terms. We don't do the inverse operation. Yeah, that's a good question. Okay, so A represents almonds. So what did we figure out? What is 2? 2 what? Yeah, so we have almonds equals 2 pounds. So how many pounds of cashews do we have? 3, because we bought a total of 5 pounds of nuts, and we bought 2 pounds of almonds. That means that we bought 3 pounds of cashews. So you could always do like 5 minus 2 equals 3. Now, these are small numbers, but you might get to larger numbers. And then this would be the cashews. So then this right here would be your final answer. Okay, let's go ahead and go to the next one. I've set these up to kind of make it easy for you to follow the steps until we get to maybe the last 2 or last 3. Just until you get used to setting these problems up. Okay, so now Macy has 33 dimes and nickels with a total of $2.50. How many of each coin does she have? So I want you to identify the 2 objects and identify the 2 characteristics. Okay. So can somebody raise your hand and tell me what the 2 types of objects are that we're dealing with here? Jules? Yeah, nickels and dimes. Okay, the characteristics might be a little bit more challenging, but can somebody tell me what I just almost said it, what the characteristics are? Even if it's just one, Maddie?
Like the value or like the total value?
Yeah, the value. I'm gonna put that here. And anyone? No. 33 dimes. Yeah, the quantity, how much? So quantity. And if you just want to put how many, you can, as long as you're using a term that makes sense to you. Okay, so now we're going to fill out the table. So you place the types of objects as the row headings on the side. So we have dimes and nickels. And then, of course, oops. And then total goes at the bottom. And then your characteristics go on the column headings at the top. So quantity and value. And now we have to fill in the table, okay? So I want you to take this step by step. Okay, let's look at the example. It says Macy has 33 dimes. Where's that gonna go? Oh, I'm sorry. Macy has 33 dimes and nickels.
Total.
Total, okay, so a good example of how you might want to read a little bit further on, okay? So that would be the total quantity or the total amount. How many? Okay. She has a total value of $2.50. So where's that gonna go? Yeah, the value, the total in the value column. So we have 250. Now it just says how many of each coin. Do we have any other information we can infer that isn't specifically stated in here? I want you to think of value. What do we know about the value of these coins?
Dimes is. Dimes is, 10 cents. And nickels is 5.
Right, so we know value. We just don't know how many. So let's look at the quantity. For dimes, I'm going to represent that by D. And then I know that each value of a dime is 10 cents. Make sure you're using the decimal form, okay? All right, now looking back at what we did for the almonds and the cashews, we took the quantity or the number of pounds, 5, and we subtracted the almonds from it to get the cashews, the number of cashews or pounds of cashews. So what can we do here? If we have a total of 33 nickels and dimes, look, 33 minus D. Okay, but then we need the value of that. The value of a nickel, please do not put 0.5 because that represents 50 cents. The value of a nickel is 0.05 times 33 total coins minus the number of dimes, which will give us the number of nickels. So, any questions about how we set up the table? Okay, so now let's go and set up our equation. Remember, we're gonna use this information here. And we do not need to multiply the total by anything this time. So we have 0.10D plus, that's the value of the dimes, plus the value of the nickels, which would be 0.05 times 33 minus D equals a total of $2.50 in money for both nickels and dimes. Okay. All right. Now, you can use your calculator to do this. So if you have your calculator, you can pull that out and start multiplying all of this. Or you could multiply the 10, the 5, and the $2.50 by 100 and move your decimals over and solve it that way. That's fine as well. So I'm going to give you a minute with your partner to solve this equation, and then we're going to come back and check our answer. And I'm also going to pause the video. Okay, go ahead and check to make sure you're on the right track. Maybe you finished it. You can check. Okay, so what I would like for you to do right now is I would like for you to read the example number 3. And I want you and your partner to come up with how to label the chart. What goes in the rows, what goes in the columns. And then we're gonna check back in, and if you feel comfortable starting to fill out the chart, you can. All right, but the first thing that I want you to practice is just being able to label the chart based on what we've done, okay? So I'm gonna give you a couple of minutes to do that. Okay, so let's go ahead. Tickets to a science fair were $4 for adults, $2 for students. If 850 tickets were sold and $2,620 was collected, how many adults and student tickets were sold? Okay, so Katrina, can you tell me what are the two objects that would go here? Adults and students, good. And then, of course, total would go at the bottom. Okay. Mason, can you tell me what would go up at the top?
Tickets.
Yeah, so, and when you say tickets, you're talking about the amount of tickets, right? So amount. Tickets, you can shorten that, and then the cost. Good. So you could put quantity and value, or quantity and cost, or just whatever makes sense to you. Okay, it doesn't have to be the exact words that somebody else uses, it's just what makes sense to you. Okay, so now we're gonna start filling in the charts. So let's see. Savannah, can you tell me what goes in my two totals columns?
For ticket count, 850, and then for the money collected, 26.
Hey, Ryan, can you tell me what goes in my two adult count columns?
For quantity, is it A?
Yep,
And then price $4, or just 4?
yeah, and you put 4A right there. Good. Yeah, then do you want to tell us what goes in the students column?
850 minus 8. And multiplied by 850 minus 8.
Good. Okay. So the next thing I would like for you to do, well, are there any questions about that? Okay, the next thing I want you to do is set up your equation. Okay. Okay, I'm gonna set it up here, but I want you to try to set it up on your own and then check with mine up here to see if you did it correctly. And then once you check that, I want you and your partner to go ahead and solve and figure out the number of adult and student tickets that were sold. And I'm going to pause the video while we work on that. Okay, go ahead and check to see if you were able to get this. Any questions? Okay. So we're gonna go to the next page. And we probably will only get one more done. That's okay. We'll finish it hopefully on Wednesday after your testing. But the next one is a percent problem. Okay, so I'm gonna go through this step by step with you. And I will say that based on, after we do this problem, based on what we've done, you should be able to do your homework. I just have 3 extra problems just to practice, okay? I tend to put more in our notes than what we need just for that extra help. Okay, so Mr. Higgins invested 50,000 in 2 ventures. He earned one earned 9% interest and the other earned 10% interest. If he earned $4,700 total. How much did he invest at each rate? So I don't know if you remember when we did the percent problems before, that I explained that when you invest something in a bank, okay, so say $50,000 in this case, and you put it in your bank, you can earn interest on it. So basically the bank is paying you money to keep your money in the bank. And so at the end of so many years, you'll have more than the initial $50,000 that you invested. Well, this guy decided to put money into two different accounts. One that would earn 9% interest and one that would earn 10% interest. Now we know the total amount that he invested and we know the amount of interest he made off of both accounts, but we don't know how much he put into each individual account. And so that's what we're going to try to find out. So when they say two ventures here, one, I'm going to mark that as A, and the other, I'm going to mark that as B. Okay. So the first account is A, which is 9%. And the second account is B, which is going to be 10%. And so that's just kind of how I do it. Account A, account B. And then of course, at the bottom, we're going to put total. Now the two characteristics, oh, I didn't put this up here. So let's just account A, 9%, account B equals 10%. Okay. So identify the two characteristics. Well, we know that he invested a certain amount. So that is called our principal. And we know he earned interest on each account. So our second column would be interest. The variable that I'm going to use is going to be A for account A so that I know which one goes to which percentage. So our principal, we don't know what he invested. So the principal would be what he invested in account A. Okay, we don't know that. But we know the interest of account A. The interest was 9%. So remember, when we put percents in equations, we turn them to decimals. So this would be 0.09A. Okay, based on what we've done before, can somebody tell me what will go here in the B column of principal? Or the B. How much total was invested? Well, no, that's your interest. How much was put into the bank total?
50,000.
50,000. So we take the total 50,000 and we minus a certain amount that went in the other account. And that is our principal. And then of course the total principal is 50,000. Okay. Now the interest for account B is 10%. So that's 0.10 times the principal amount. And your total interest is 4,700. Okay. So here is principal and interest. Now the way that you set up the equation is the same. Okay. We're going to use the right column. And we set it up as 0.09A plus 0.10 times 50,000 minus A equals 4,700. Okay, and then you're going to solve it just like we did on the other one. And you can clear your decimals if you want, but you don't have to. Remember, if you do multiply everything by 100, 4,700 becomes 470,000 because you have to add 2 zeros onto that. Okay, so I'm going to give you a minute to solve that right there. Okay, so I'm gonna go ahead and show the answer so you can check your work. Yes.
If you clear your decimals, do you also clear for what's inside of parentheses?
No. That was a good question.
30,000.
Well, I solved the equation that we originally set up, so once you distribute your 0.10, you should get 5,000 minus 10.10 A. And then 0.09 minus 0.10 A is 0.01 A, negative. So then and then you subtract 5,000 from both sides, you get negative 300, and then negative 300 divided by negative 0.01 is 30,000. Okay, so example 5, like I said, is very similar to example 4. So I'm going to fill out the chart and I want you to check to see if you did this correctly. You should have principal and interest. Those are the two characteristics of your two accounts. So again, I'm going to set this up as account A at 8% and account B at 13% with my total down here. Okay. Now, when I look at this, I look at the information that I know or that I see within my problem. So a total of 40,000 was invested into two ventures. So I know my total principal invested is 40,000. It says that the first yielded 8% interest. So here's my first one, 8% interest. So I'm going to title this one A at 8% interest. Okay. And the second one yielded 13% interest. So I know that this one over here is going to have a 0.13. All right. And remember, the principal amount that was invested in account B has to be the total minus the amount that was invested in account A. So say we had 10,000 that was invested in account A. We would take 40,000 minus 10,000 and we would get 30. So we're going to apply that same rule here. We're going to take 40,000. We're going to subtract the amount of principal in account A. We don't know that amount though, so we're just going to put minus A. Then the interest is 13% on this account, on the principal of that account. So it's 40,000 minus A. And the total interest that was made is the 4,500. Okay, so now I want you to create the equation for this account. And when we come back, I am going to, you can check your work. You can check the equation and you can check your work. So I'm going to pause the video while you do this. Okay, if you're ready, go ahead and check your work. And you can pause the video if you need to check. And then we are going to go ahead and move to the back. Okay. All right. So let's look at number 6. Riley has a bag of 300 dimes and quarters. If the total value of the coins is $40.95, how many of each type of coin does she have? Now, what I want you to do on this one is I want you to use example 2 that we did on page 2 to help you with this. And I want you to go ahead and set up your table and fill everything in. And then I'm going to then I'll pause the video and then you can come back to check to see if you did it correctly. Okay. Okay, so here is the chart filled out. And so what you're gonna wanna do now is just make sure you understand what you're doing, that your chart is correct, and then you're gonna set up an equation and you're gonna solve. Okay, what I would like you to do now, if you're watching the video, I want you to go ahead and pause the video and I want you to work this out because right now I'm going to show the answer. But I want you to give yourself enough time to work it out to make sure you're understanding what you're doing. So go ahead and pause the video. And I'm going to show the answer right now. Okay, so you should have gotten 227 dimes and 73 quarters. If you add these up, you'll get 300. And then if you plug these values into, or if you plug 227 into the dimes, or the D of your equation, you should get a value of $40.95. Okay, so you could always go back and check your work by doing that. Okay, let's go ahead and move on to number 7. A baker sold 2 dozen cookies with a mixture of chocolate chip and sugar cookies for $20.70. If chocolate chip cookies sold for 90 cents each and sugar cookies sold for 75 cents each, how many of each type of cookie did the baker sell? So again, I'm going to give you an opportunity to fill in the chart. And the first thing that I want you to do is just fill in the rows and the columns on the edge to make sure you have that correct, because this one's a little bit different. We're going to come back and check it, and then I'm going to pause the video again and have you fill out the chart. Okay, so go ahead and fill out the titles of your rows and columns. And I'm going to pause the video. Okay, so this is how the title should look. You should have quantity and value up at the top. And on the side, you should have chocolate chip, sugar, and total. And so now I want you to take the information in the word problem and complete your chart. And then we'll come back just to check your work on that before we complete the equation. Okay, so I'm going to pause the video. Okay, so here is the chart completed. One thing that you needed to do was take the 2 dozen, and because they're selling cookies individually and not by the dozen, you would need to give the total quantity within the 2 dozen cookies that they're making. And so you have 24 as a total rather than 2. Okay, so now what I want you to do is I want you to set up the equation and solve. And you're trying to figure out how many chocolate chip cookies did the baker sell and how many sugar cookies did the baker sell. So I'm going to pause the video while we work on this. Okay, so this is the last problem that we did. You should have gotten 18 chocolate chip cookies and 6 sugar cookies were sold by the baker. And again, if you want to go back and check your answer, you could plug 18 for the chocolate chip cookies into the equation for C and see if your left side and your right side both equal $20.70. Okay, and that concludes our lesson 2.8 notes.